You know how you've all know Harari talks about shared stories?
Mhm.
How they're this like incredible superpower for humans, letting us cooperate on just a massive scale.
Yeah, it's a fundamental idea.
Well, it got us wondering, could something similar work with AI? Specifically, um, can we actually use narratives, stories, to nudge large language model agents towards collaborating?
You mean these digital minds we're building?
Exactly. Because if we can, that's potentially a huge deal, a real game changer.
That's pretty much the core question behind this fascinating new research paper. It's called The Power of Stories. Narrative priming shapes how LLM agents collaborate and compete.
Okay.
And their whole goal was basically to see if these narratives, they actually called them digital bedtime stories, which is kind of fun, could genuinely influence how AI agents cooperate or, compete.
Digital bedtime stories. I like
Yeah.
that. So how did they test it?
Well, they set up this clever experiment. They had LLM agents play a repeated public goods game.
Ah, okay, like the classic game theory setup.
Exactly. Think of it like maybe a digital potluck. Everyone gets some resources, decides how much to put in the shared pot, and then everyone benefits from the total. But crucially, there's always that temptation to hold back, right? To just take without giving.
Right. And they primed these agents with different stories before the game started.
Precisely. So, for you listening, if you want the quick but thorough scoop, we're going to break down how these stories affected how the agents negotiated.
Okay.
What happened when they all heard the same story versus different ones that turns out to be really key.
Interesting.
And also how things changed when they scaled up the number of agents, and whether this cooperation could even survive when faced with purely selfish agents.
Sounds good. Yeah, the results I hear were pretty surprising.
They really were. Let's dive into the game itself first, the public goods game.
Okay, lay it out for us.
So picture a group of these AI agents. Each one starts with, say, 10 digital tokens, just an arbitrary amount.
10 tokens. Got it.
Then, in each round, they secretly decide how many of those 10 tokens could be 0, could be all 10. They want to contribute to a shared pool.
Secretly. So they don't know what the others are doing in that exact moment.
Not in that moment, no. After everyone decides, all the contributed tokens go into this central pot. And here's the kicker. Whatever is in that pot gets multiplied by 1.5.
Oh, okay. So there's a bonus for contributing.
A collective bonus, yeah. Then, that multiplied total is divided up equally among all the agents, and this is important equally, regardless of who put in what.
Ah, okay. I see the tension immediately. If everyone throws in everything, the pot grows significantly, and everyone gets a great return because of that 1.5 multiplier.
Exactly. Maximum collective benefit.
But for any one agent, thinking purely selfishly in that single round,
Yeah.
the best move seems to be putting in 0, right? Because you keep your 10 tokens, and you still get an equal share of whatever the others foolishly contributed and got multiplied.
That's the dilemma, perfectly put. It's that classic conflict. Individual self-interest versus the collective good.
It makes cooperation tricky.
Very. But, and this is crucial, they didn't just play 1 round, they played 5 rounds.
Ah, okay. So they could learn, see what happens.
Precisely. It allows the agents to see the outcomes, see the total contributions perhaps, and adjust their strategy over time. It opens the door for a kind of implicit negotiation, learning from behavior, not words.
Right. They adapt.
Yeah.
So where do these bedtime stories fit in? How did they actually prime them?
So before the game even started, when each agent got its initial instructions, its prompt, basically tucked inside that prompt, was a short piece of text, the bedtime story.
Just slipped in there with the rules?
Yeah, almost like a background context. The researchers framed it as something the agent had been told repeatedly, shaping its, let's call it a worldview, a prior belief.
Interesting. So what kinds of stories were these? Were they like Aesop's fables for AI?
Sort of. They had 12 different conditions. 8 of them were narratives specifically chosen to highlight themes of cooperation, teamwork, shared benefits, things like that. They picked stories aiming for a bit of variety, even cultural diversity, apparently, but used them in summarized forms. Pretty short, actually, averaging around 1,200 characters.
So concise little nuggets of narrative.
Yeah.
And the other 4 conditions.
Those were the controls. One was just no extra behavioral instructions at all, baseline.
Makes sense.
Another explicitly told the agent, your goal is to maximize your own rewards. Just straight up self-interest.
The opposite of cooperation, basically.
Right. And then they had 2 really interesting ones they called nonsensical stories. Just jumbled words. Gibberish, essentially, designed to see if just any text input had an effect or if it needed to be meaningful.
Okay, so a good range of inputs. Cooperation-focused, self-interest, nothing, and nonsense. Got it. So let's talk experiment one. Everyone gets the same story. Homogeneous groups, what happened?
Right, the homogeneous setting. 4 agents, all primed with the exact same narrative. And to measure what happened, they use this thing called a collaboration score.
How did that work?
It's basically a percentage. It measures the total tokens everyone actually contributed across all rounds, compared to the absolute maximum possible if every agent had put in all 10 tokens in every single round.
So a score of 1.0 would be perfect cooperation.
Mm.
Everyone all in all the time.
Exactly. And zero point 0.0 would be zero cooperation. It gives a nice, clean number to compare the effects of the different stories.
Okay, so did the stories make a difference? Did the shared narrative actually change that score?
Oh, absolutely. Big time. The results were pretty clear. Those agents that got the nonsensical stories, the gibberish,
Yeah.
or the ones explicitly told to maximize their own reward, their collaboration scores were significantly lower. Much closer to 0.
Okay, that kind of makes intuitive sense. No cooperative push or an anti-cooperative push leads to less cooperation.
Right. It suggests that without some kind of cooperative framing or with that direct self-interest nudge, they just don't work together as well.
What about the cooperative stories? Did they actually manage to boost the score?
Yes, several of them did. Certain narratives, ones they labeled Old Mansons and Turnip, presumably based on actual fables or stories emphasizing teamwork, resulted in significantly higher collaboration scores.
So the content mattered. It wasn't just having a story. It was having a pro-social story.
It strongly suggests that, yes, the type of shared narrative genuinely seemed to shape how cooperatively these LLM agents behaved. You could almost see a spectrum based on the story they all shared.
That's pretty wild.
Yeah.
Did this hold up if the group got bigger? I mean, 4 agents is one thing, but what about 16 or 32? Does the story still bind them together?
Remarkably, yes. They scaled it up, tested groups of 16 and 32 agents, all getting the same story. And the overall trend held.
Really?
Yeah, the relative ranking of the stories, which ones led to more or less collaboration, stayed largely the same, even as the group size ballooned. Story A might be better than story B in a group of 4, and it was generally still better in a group of 32.
Wow. So it scales to some extent. That's significant.
It definitely hints that this isn't just some weird artifact of tiny groups.
Okay, but reality isn't always cooperative. What about resilience? Did they test what happens if you throw in a defector, a purely selfish agent?
They did. They ran another test with groups of 4, but this time, one of the 4 was hard-coded to always contribute 0, a persistent free rider.
The ultimate test for cooperation, right?
Kind of, yeah. And, well, as you'd probably guess, the overall collaboration score dropped across the board for all the narratives when this free rider was present.
Makes sense. People or agents aren't going to keep giving if someone's clearly exploiting them.
Exactly. But importantly, the relative effectiveness of the cooperative stories still seemed to hold, just at a lower level. And interestingly, the other agents didn't just give up or stick to one strategy. They observed that the agents seemed to dynamically adjust their contributions in response to the free rider. They weren't just blindly following the story, they were adapting strategically within the context provided by their initial narrative.
So the story sets a kind of baseline tendency, but they still react to the environment.
That's what it looks like, yeah. Learning and adapting, influenced by that initial prime.
Okay, so shared stories seem to nudge everyone in the same direction, fostering cooperation, even with some bumps. But you mentioned a twist. Experiment 2. Heterogeneous agents. Everyone gets a different story.
Exactly. Now things get really interesting. In this setup, each of the 4 agents in a group got a random story drawn from the full pool of 12, the cooperation ones, the selfish one, the nonsense ones, the no instruction one, a real mixed bag in every group.
Like walking into a meeting where everyone has completely different agendas and background briefings.
A good analogy. And this is where the results basically flipped on their head. It was, yeah, quite unexpected.
Flipped? How so? What happened?
Well, remember how the max reward instruction led to low collaboration in the shared setting?
Yeah, the selfish instruction.
In this mixed setting, agents who got that max reward instruction actually ended up with the highest individual payoffs. They did the best for themselves.
Wait, really? Being explicitly selfish worked better when everyone else had different instructions.
It seemed to, yes. Even the agents who got the nonsensical stories did relatively well in terms of payoff, almost as well as those with no instructions at all.
Huh. So, lacking a coherent story or being told to be selfish was actually good. in that chaotic environment.
It appears so.
Yeah.
And conversely, those agents primed with the strong cooperation stories like Old Manson's or another one called Spoon's, they actually ended up with lower individual payoffs in these mixed groups.
Wow. So the pro-cooperation stories hurt the individual agent when the group wasn't on the same page.
That's the implication. The researchers concluded that the power of a narrative isn't just about its message cooperation good, selfishness bad. It critically depends on whether that narrative is shared by the group.
Common ground is key.
It seems to be absolutely essential here. When everyone has a different story, a different prime, the cooperative nudge seems to fail, and a more self-interested approach becomes, well, more successful individually.
That is, yeah, that's a really profound finding. It's not just the story, it's the sharedness of the story.
Exactly.
So let's pull this together. What are the big takeaways for someone trying to get a handle on this? What does it really mean?
Okay, the number one takeaway. Yes, narrative priming is a lever. We can apparently influence LLM agent collaboration using stories. That's confirmed.
Right.
But the really crucial, perhaps surprising insight is that how it works depends massively on shared context. Homogeneous groups' shared stories foster cooperation. Everyone benefits more.
Okay.
Heterogeneous groups' diverse stories seem to undermine cooperation and actually make competitive, self-interested behavior more rewarding for the individual. The lack of common ground changes the game.
That has some pretty serious implications, doesn't it? Thinking about designing multi-agent AI systems.
Huge implications,
Yeah.
or even for AI alignment, right? Ensuring AI behavior aligns with what we want.
Yeah.
It strongly suggests that if you want AI agents to work together effectively, especially towards a common goal, maybe ensuring they operate from a shared conceptual framework, maybe even a shared narrative about the task could be vital.
Giving them all the same mission briefing, essentially, but maybe in story form.
Could be. Now, the researchers are quick to point out they're still digging into why this happens. The exact mechanisms aren't fully understood yet.
Right, it's not like the AI understands the moral of the story like a person does.
Probably not, no. Is certain words in the stories triggering associations from their massive training data? Is it something about how they were fine-tuned with reinforcement learning? Is it just complex pattern matching? These are big open questions.
So, caution against anthropomorphizing too much. Their cooperation is likely statistical.
Exactly. We see cooperative behavior, but the underlying driver is complex and likely very different from human motivation. Still, the effect itself is real and measurable.
And it opens up a lot of doors for future research, I imagine.
Oh, absolutely. Where do they go next? Well, definitely more work on those causal mechanisms, trying to peek inside the black box with interpretability techniques.
Makes sense. What else?
Exploring how long these priming effects last. Is it just a short-term nudge, or does it persist? What about malicious narratives? Could you prime agents for bad behavior?
Ooh, that's a slightly scary thought.
It is. Also, testing different story genres, different LLM architectures, scaling up to even larger groups, and doing a more systematic analysis, breaking down stories by structure, emotional content, how explicitly cooperative they are.
And comparing AI strategies to human ones.
Exactly. Mapping how these primed LLMs play the game compared to human players or established game theory models. Lots to explore.
So, wrapping this deep dive up, the core insight seems to be that stories, this ancient human tool for cooperation, surprisingly work on AI agents too.
They do, but with that critical twist.
The twist being that sharing the story is the magic ingredient. Shared narratives foster cooperation. Diverse narratives seem to lead back towards competition.
That's the crux of it. The contrast between the homogeneous and heterogeneous results is really the standout finding here, with big implications for how we design and maybe interact with AI systems in the future.
So here's something for you, the listener, to chew on. If we can, in fact, prime AI behavior with stories, what does that really tell us about influence itself? Not just in AI, but maybe in all complex systems, even our own societies. And maybe more pointedly, what happens when the stories we tell our AI systems start to clash with the stories we tell ourselves?
Yeah, what happens when those narratives conflict? It's
Yeah.
a lot to think about.
Definitely. If you want to dig into the nitty-gritty, the paper we've been discussing, The Power of Stories, is out there. And the authors even shared their code on GitHub if you're technically inclined.